April edition of SacPy. Welcome everyone. It's April 6th, SacPy. We are online. We've been online now for just over 3 years, thanks to the pandemic. And honestly, I couldn't be happier with how things turned out. The group has grown and it's definitely, I think, reduced friction for some of our attendees and some of our guest speakers. So thanks everyone for showing up. We had a milestone recently, crossed 1,400 members on the meetup group. So kind of exciting. When Robert and I took over back in January of 2020, we were in the 700 range. So I'll hail the glorious founder of SacPy, Josh Miller. He's on the invite list tonight. I made sure to specifically reach out to him, but unfortunately he was unable to make it. We'll send him the recording so he can see where his baby has gone off to in his absence. I think he's off in Tennessee these days, which understandably was a little bit difficult considering we were meeting in person, but now that we're meeting online, well, he's actually shown up to a few. So in any case, thanks again, Josh, for getting us started. Honored to have had the chance to continue things. Yeah, so we got a number of channels out there. I don't know how useful these QR codes are, but they do work. Also, we got some links. Ooh, and we did a little bit of shakedown, and so I'm gonna provide those links in the chat. So first and foremost, we got the SacTech Slack, which is in the links there. And we've got, that is a group out of Sacramento. I believe it's a consulting group, number of different focus areas. Brazen Studios is my company. I run the Discord there, and we've got a channel and stage for SacPy. So I'm in both of those and pretty responsive. So if you want to reach out, propose, say, topic for speaking or something like that, or just generally questions about Python, I'm pretty responsive, and a bunch of the community is in there as well. We are also in a number of other social media channels. We've got Twitter. I tweet a little bit. We got a subreddit. We also have a Facebook group and a Facebook page, just for good measure. Those get updated about as regularly as any of the rest of it. The theory there is it's approximately, if you build it, they will come. We also have a LinkedIn group that was formed relatively recently. Please feel free to join us in there. We'll be putting events on there. Jim has recommended that as a place to post. Oh, it's just, I was noticing some tiny sounds there. It's Twinkles is going nuts on the the headset.
Oh, sorry about that. Yes,
that's okay. No worries. Yeah, that's Donnie and Islam from Lawrence Livermore National Laboratories. He's our MVP for guest content, and Twinkles is our mascot. Twinkles is also Instagram famous, so if you get the chance, say hi. All right, before we get into the meat of the evening, now's your time to hop on the camera. I'm going to stop my share here so we can get a clear view of the audience. I'm going to take a quick screenshot here. How do we get the gallery? There we go. So if you'd like to be on the Brady Bunch photo, we'll do a few screenshots. Link to Discord, Greg, if you scroll up, I believe it's in there. All right, everyone else who's getting on there, smile, try to look intelligent. This will be immortalized in the future. Awesome. Thank you all. Okay, so part of this, I run this thing out of my company's resources. The intent is to eventually become a nonprofit once we get to critical mass. Every quarter, I'll do a brief update on things that are going on in my world. Since this is a larger crowd, I figure I might as well explain myself a little bit. I like to operate in the internet space for the last, let's see, 8 years or so under the moniker Frymatic. Frymatic is a character that is in my GitHub and my SoundCloud, and I'm on Discord and Twitter and a whole bunch of other things. It's kind of my avatar. And the idea there is Frymatic is the right head of Racing Studios and is like the final boss of a video game I'm working on. So this is the quarterly Frymatic update. 4 main bullet points. Most recent hackathon was an OpenAI one, holiday I've been running since 2015, and then a handful of the new customers are in the fold now. So we did an OpenAI hackathon recently. It was by this group Lab out in Sweden. Thanks for running it, guys. That was a lot of fun. And my team was, I think, mostly Pacific this time. I've done some teams that were, like 12 different time zones. This was a little bit more restful. When you have those 24/7 teams, you can miss sleep a little bit. So it's a little nicer. We did a Dune themed product. It was the idea was that it was an AI tutor, so it was kind of counterintuitive if you know the Dune lore to call it Mentat. I suppose it should have been called Evermind or Omnius or something like that, but we had fun with it. It was AI tutor for personal knowledge management. We used this format called Zettelkasten, which is like old school card management thing. But we used the embeddings in OpenAI and made like a Next.js web app that allowed you to kind of go through and build cards out. I don't know, we did okay. It was fun. Just before the last SacPy, or rather right after the last SacPy, was this holiday I've been running for a while called Mars Day. I registered in a handful of places. We're up in the National Day Calendar and Chase's, and I think I applied a few more. So I don't know if I'm going to Mars, but in the meantime, what I can do as a guy with like a marketing background and social media was made a holiday. Kind of fun. I like wear red and do stuff for the holiday. It's fun. New clients are in the fold. In case anyone's interested in doing some data science projects, I'm working with this group called My Legal Coach. The idea is right now it's coaching between lawyers, get coaching from a lawyer as a lawyer or from a lawyer as a potential client. Eventually we'll turn this into like a case management product suite, but attorneys are signing up, and then I'm kind of doing some scraping of the internet at large. A lot of beautiful soup type stuff. As you can see, I've got a whole bunch of different approaches that I've been taking. It's been fun. Some of the data that's out there about attorneys that we might want to have in our client base is a little dirty, but a little beautiful soup, and get it straightened out. Been fun though. And last but not least, one of our current attendees here and a regular in the community with SacPy, Jim Slavin's Agile Cloud Institute. We've been talking for the last few weeks, and I'm going to be coming on board as a reseller for their cloud management suite that they've put together. And this is their answer to kind of like old school ERP services. So looking forward to training tomorrow, Jim. Yeah, so all right. So now that we've got the quarterly update out of the way, let us move on to the main event. Okay, so our guest of honor tonight is Travis Oliphant. This guy does like everything under the sun and a whole lot of it Python. He's definitely one of the most prolific open source minds out there, and we're privileged to have him here tonight. Once again, thanks to Jared for coordinating. Typically when people come on to SacPy, they do sort of a presentation, show and tell, demo thing. And Travis, you're welcome to do that tonight. But I figured we'd structure this conversation a little bit more like an interview, talk about things you've done in the past, your approach, and why you do things and whatnot. But
sure.
Before we get started on the talking points, I figured give you a chance to introduce yourself. And
sure.
Then,
yeah, I do have a few slides I can just talk to. If you don't, I can share. I mean, I appreciate the format. It's very flexible. We can talk about a lot of different things. I'll share my screen if that's okay.
Sure. Should be able to.
Yeah, if you'll see that now.
Python exploration.
Yeah, just a little bit. And now I have to figure out how to actually view this. You'd think after years I'd be. The problem is I've gone between different presentation software. I really haven't settled on something. I've actually been using a lot of Google Slides these days. Tried a little Slides GPT. Had a little. I needed to put a slideshow together for a client, and I told them I was going to use GPT, and it actually generated a lot. It was very interesting what it generated. It's kind of that's definitely a topic on a lot of people's minds today. I'm sure there may be some questions there. I don't know that I know more than many of you about that topic, but I can certainly understand. I understand how they're built. I understand how large language models are built pretty well. But in terms of their impact and what they're going to do for us, that's an open question. But it's interesting to me the power that Python played and that open source played in producing these incredible innovations. And I do want to talk a whole lot about. I'd love to talk about that. I've been around for a while. I'm getting a little older. I've been using Python since '98. I think I'm not the oldest user of Python here, I don't think, but I have been using since Python 1.4 and saw the Python 1 to 2 transition, the Python 2 to 3 transition. I really got into the Python community because of my interest in science, and I started the SacPy project. It used to be it was actually called Multipack back in the day. It was a collection of extension modules. I really enjoyed that experience. In fact, it led me on a journey away from. I was an academic. I was at the Mayo Clinic. I was studying science. It led me on a journey out of academia. Finally, I was a professor for a while into entrepreneurship because I wanted to understand how to make open source thrive. So that's really been the journey for the past 20, 22 years, even 25 years, has been trying to figure out how to make open source work. And lots of other folks are involved in that journey. And that's been the glorious part of it. Is the thing I love about open source is the community and the people you get to know and interact with, and the opportunity just to help. And it turns out it's the same thing I love about business. It's the opportunity to help, to provide help, to do something useful for other people, to work with them. And so I really have found a lot of enjoyment in that. And Python's been at the heart of it. So I started SciPy, and then as a professor, I wrote NumPy, and then left academia, came to Austin, Texas 15 years ago, joined a consultancy called Nthought, worked there for about 4 years, and then ended up starting a company with my friend Peter Wang. We started Anaconda, and also at the same time started a nonprofit, NumFocus, and then created the PyData ecosystem. Then at Anaconda, I was there for 6 years as the founding CEO, learned a ton, raised money, got investor money coming in, and then eventually I ended up leaving there. There's stories behind all of this, and we don't have to go into any of it, or we could go into more of it if you'd like, if you have questions around this, because of course behind the scenes along the way, there's technology that I'm deeply passionate about. So NumPy and SciPy came before. While we were at Nthought, tried to build more about that, did a lot of work in visualization and in UIs, GUIs that used NumPy and SciPy. And Anaconda, we were able to produce Conda and Numba and Dask and Bokeh and a bunch of other software that helped scale Python, and then the Anaconda distribution, and really for helping the data science story emerge. And then, knew all the people around Jupyter, knew people around Pandas, started using them heavily. Scikit-learn came out of the SciPy growth. And then, of course, in 2014, 15, TensorFlow, PyTorch, these large systems that were NumPy-esque, but had a lot more around it. So that's what I've been doing. And then 2018, I started another company, Quantite, really sort of recreate the foundations of what I learned at Anaconda. I wanted to basically help other people create startups. And we did that by creating a consulting company and then an incubator, a venture fund. And so, these days, I'm basically, I look for tech visionaries, founders, investors, and leaders to help build technologies, funds, companies, partnerships, and new movements. I'm still deeply focused on sustaining and promoting prosperous community-driven open source. That's what I do every day. We have a Quantite Labs I'm really proud of. We finally created an organization that funds and sponsors SciPy and NumPy. Like, that was my whole goal, to come into Texas and try to build a company that could actually fund and sustain my open source addiction, essentially, to writing code in community fashion. It took a while, and there's different ways to do it. We've uncovered, and it's a great topic of conversation I'd love to talk about, is how do you do it? There's lots of ways. There's some that work better than others, I think, and but that's what I'm doing right now, is basically working on a bunch of these things. Right now, there's this concept called open teams, multiple aspects that Open Teams is involved with, and happy to talk about any of these things, but can talk about whatever other people want to. Open Teams is focused on, Open Teams itself is focused on what we call open source architects. It's technical leaders and giving technical leaders opportunities at clients. And then we have a project success program that helps those technical projects go well. And we're using AI, we're using tools to try to make information about those projects go well, all learning the lessons of the past 15 years of consulting, essentially. And then Open Teams Incubator has a fund, and we fund entrepreneurs, and we have entrepreneurs in residence, and we help people create startups. And very excited about essentially Open Teams and Global are both incubated companies. And then Open Teams Global is a talent cloud, and its goal is to help people. Particularly, we sponsor a program called ospn.org. You can go there today. ospn.org is a place for people to promote to register. It's essentially a LinkedIn for open source creators. And our goal there is to find people all over the world and help get more people participating in open source creation, and then finding opportunities and jobs in organizations that support their desire to contribute to open source communities. And there's a lot more organizations that do that, but there's still some things you need to do to make sure that you're doing the right thing there. So that's what that's what Open Teams does. And Quantite is a consultancy, wonderful group of people at Quantite. We do data science consulting, the Pi data experts, you could say. And we have a product, I can talk about a project we've been working on there called Nabari, if people are curious about a particular project. And it's an open source data science platform. It helps people get started without a lot of experience in DevOps. It helps people get started getting all the tools needed to really do things like train LLMs or do data science analysis or do ETL processing on data. One way to think about it is Anaconda is a way to get all the packages you need to run on a machine. Nabari is a way to get the environments you need to run on a cluster. That's one way to think about it. But it pulls together tools, and it's completely open source. And Quantite's a combination of a consultancy and a labs. Labs is led by Rolf and Tanya, and our consulting practice is led by we have a bunch of people managers and some wonderful people who lead. My partner, Matt Harward, is someone I've worked with for years. To create these businesses. He's a sales expert and someone who's really taught me a lot about how to sell and how to help people. So that's what I'm doing right now. It's pretty busy. It takes a lot of effort. I love it because it helps me stay connected to open source communities. Helps me allows me to keep participating and sponsoring and funding the projects that I had a hand in creating and I still want to see thrive, and then also kind of still be involved in helping many more open source projects and companies come into existence. So I'm still, I'm not on the board of Anaconda anymore, but I still work with Anaconda people every day. It's still a company I love and I founded. So that's what I do. I'm happy to talk about any of that. I'll just, I'm interested in a lot of tech still, and I'm happy to talk about some of this tech. I'm very interested right now in a static compiled Python. Numba was a project I started in 2012. It's a Python compiler. And now there's many of them. And Python is sitting there as an extension module creator. And I'd love to kind of work with people to kind of create or try to help the static compiled Python story become even more robust. And really there's an opportunity for a new language, I think, as kind of a sub-language of Python that we could create. Happy to talk about packaging as discontents. A scientist turned founder of a company that does packaging. Sort of an interesting story. How'd that happen? And because of SacPy, basically SacPy is a package masquerading as a library. Arrays, data frames, parallel computing, numerical advanced algorithms. Happy to talk about anything there. And then Python type systems and meta classes is an area. Python 2 did a really great thing in kind of exposing the meta type. And I wish I'd have understood that better when I was writing NumPy, because I would have done a better job of creating dtypes, I hope. Right now, NumPy, essentially, its type system is a Python 1 era type system. If I'd understood better, we could have created something better and more powerful there from the beginning. It didn't occur to me how to do that until about 7 years ago. Still like talking about it and happy to talk with folks about it. I don't get a chance to hack on that and try to build something. Maybe I should take the chance or try to play with that someday. And then distributed ledgers and the distributed web, the Web3. I call it DWeb instead of Web3, but I like that whole space of conversation. So that's kind of what I wanted to say. And then there's many, many more things to say. You know, I love the community. I think that's the most critical thing and the most excited thing. The happiest thing I've done is just code with a bunch of people. And I think that's the part that's the most fulfilling and the most done the most good, honestly, because it's not what I've done individually, it's what we've done together that's actually made a big difference in the world. And that's what's astonishing, honestly. I would not have predicted the impact that we've had as a Python ecosystem 20 years ago. And it's a significant impact. I mean, you think about the things that are happening right now on the tip of the iceberg, and it's because of the work of all these wonderful people who have built these tools that created an ecosystem that would enable, you know, large language models to emerge, generative AI to emerge, and the future to emerge. And I would like to ensure, I would like to see what we can do to make sure that future is as bright as the past. And so, you know, I do care about that. I care about, you know, doing well by doing good. And what does that mean? And there's still a lot of questions out there to talk about. So yeah, I think at this point, happy to, you know, Brendan, if you have questions or you want to have another dialogue with other people, happy to talk about any of those things in more depth.
Awesome.
Hi, Travis. This is Donnie, the guy with the parrot. And
Parrot,
I also
yeah.
I work at Livermore Labs, actually. I've been there
Oh,
for
yes.
12 years now. And
Yes.
I'm going to probably do a blast from the past kind of question or discussion, if you're fine with that.
Sure. Yeah.
Paul Dubois and David Beasley.
Absolutely.
You remember them working on a code called Cull. So its secret sauce was basically a Python layer on top of this big rad hydro, you know, parallel simulation code. Does this ring a bell with you at all?
Call?
K-U-double-L.
Oh, K-U-double-L.
Yes.
Oh, and not enough. I mean, obviously Dave Beasley does, obviously Paul Dubois does, Lawrence Livermore, lots of great people there, and significant people in the origins of Python, in numerical Python. Cole, no, I didn't get a chance to work with it.
Oh, you didn't, but
No,
I
not
think Paul
directly.
Dubois was a Cull developer.
It could be. I know he did Eiffel. He did Eiffel, and then the array library in Eiffel.
Oh, okay.
That's what I knew he did. But of course, we knew each other primarily via mailing lists, and we met in person a handful of times. You know, and I see, and unfortunately, enough times that we're Facebook friends, and so I do continue to see his one of his posts there.
Okay. Okay, then I can ask a more general question rather than specific or leading loaded question. Swig, good idea or bad idea? Because it seems like it was a very early solution or implementation of wrapping C++ into Python.
Yep. Swig was the very first thing I used, honestly. I used Swig to wrap FFT libraries. So that's how I got to know, Dave Beasley. So I'm in the camp that it was a good idea to build something like that. The challenge is a significant effort to do it well. And, it got to the point where having one person try to maintain Swig was just not, it's just untenable. It's sort of almost like, here's a reference approach to how to do this. In general, I would say, I am a big fan of actually, extension, like that Python should have had a mechanism to create extensions earlier. Like I was on a circuit a few years ago talking about ePython, which is a conceptual a way to extend Python with a single language. There's been lots of ways to do it. Swig is a wrapper generator. NumPy has inside of it currently something called
F2Py. F2Py, for instance.
Yeah.
I use that every so often.
Yeah, F2Py is embedded. I mean, it comes with NumPy because I used it quite a bit. When I was writing SacPy, Piaro was a student from Estonia. He was one of the people actually that I remember kind of taking my original release. I put something out on the net, and he downloaded it and put back a makefile that I'd never seen something so complicated before. It was actually, I was like, wow, I didn't know makefiles could do that. It was making breakfast for me in the mornings or something. So he was very talented. When he saw me, I kept releasing libraries during 1999. Actually, here's a wrapper of QuadPack. Here's a wrapper of a minimization library from this Fortran
Right.
code. I just kept
Became
doing that.
SacPy. Yes.
I was kind of just hand wrapping them. You know, I wasn't using
Oh yeah,
Swig. I
you were
used
a
Swig a
grad
little bit.
student then, so you
I was a
had the
grad student.
impetus.
Exactly. So, you know, I had time, right? And so I was learning, and I would go through the hassle of doing I could write some C code. And so that's what I did. I became a really good extension writer for Python. That's actually the core element of my skill. But then he came along and said, "Hey, what are you doing this manually for? I'll just write a tool that will parse the Fortran and produce the extension code." And so I was like, "Oh, well, I hadn't contemplated even trying to do that, but that's pretty cool." And we helped debug some of the more tricky parts of FTPy, like the double entry callback mechanism, like how do you do callbacks? Because you wrap a function that then the Fortran code has to call back into Python, and that Python code could then be reentrant and come back into the extension module. So there's things you have to do to make sure it doesn't segfault, basically. So we built that into SciPy. There was things I had done in wrapping QuadPack that we replicated in the FTPy. So there was some fun work there actually with Piaro, but he did the heavy lifting. I just did a couple of things there. But FTPy came out about the same time as SciPy, and has been instrumental in every release of SciPy since.
Right.
Now I think we're finally getting. I'm probably expecting the next maybe 5 years that era is ending. A lot of people, there's a lot of push to migrate Fortran, except for Andrei Surtek. Have you heard of him? Andrei Surtek is another National Lab guy. Loves Fortran. He's created
It's
LL
fast.
Fortran.
It is
It's fast. I agree. I love wrapping Fortran. Honestly, I love wrapping Fortran more than I love wrapping C++ or
It's a simple
C.
spec, so yeah, you can't do much with it. It's great, right?
For writing subroutines, I still think it's the best option.
Yeah.
Like you just want to write a subroutine, it's a little bit different syntax, but it's not that hard. And it's pretty cool. It has a nice array library and that complex numbers supported. It's actually pretty good.
So do you have a lot of experience or at least intersection with or exposure to Python steered, scientific codes? I know of Cull, but I don't know of other ones.
So I'd had some exposure to some of the ones out of Sandia and Argon.
Oh, PMesh is another one. PMesh is another one too.
PMesh I'd heard of.
I use that all the time. It works very well. It's among the many children I use, it's not one of my problem children.
Are you running on supercomputers these days? Are you HPC
all the
clusters?
I have a REPL, process with supercomputers. I need to run. I have a cluster. If I need to run a 36 or 72 processor job, I use Mika for sort of debugging at that level. At least it's not going to die on birth. That's sort of yes. So I use a lot of pandas, a little bit of F2Py, a lot of PMesh and stuff that pre and post processes, the results of rad hydro codes. And I yell a lot. That's why I keep my door closed also. There's an intersection too, Robert Kern. I heard that you've interacted. I mean,
for sure. Yeah, so we worked together at
intersected a little at Caltech as undergrads.
Yes.
Remember, we were in the Ruddock, computer lab, Ruddock dorm computer lab, commiserating about how Caltech is terribly hard. So I know he knows me. Yes.
Robert Kern, I started to meet him on the internet in 1999 because he took my multi-pack. My releases were terrible. They were the web page I released on is a tarball. You go down, you click on it, download a tarball, and install it. And the nice thing is you can install it anywhere if you had enough desire to do builds. And but then Robert Kern took those builds as I think he was a high school senior. Honestly, at the time before he went. At the time he was a student in high school. He took those and created Windows binaries.
Yeah,
now, I was not a Windows developer at the time. I had just done Linux, and I didn't know what to do for Windows binaries. So, and Linux binaries were useless. So at the time. So he made Windows binaries, put them up on the net, and I said, "Oh, thanks. We'll host those." That's how everybody got multi-pack. And then all of a sudden, downloads skyrocketed once people could install it on Windows.
There you
And
go.
so that actually was a big lesson. This is ultimately because of that, Anaconda exists today, effectively, because that was what taught me about the importance of binary distribution and to get people to run the software you created, and the problem of how do you get this stuff installed.
Yeah,
So,
if you give more than 2 steps to it,
Yep.
you've already lost your
Yep.
potential client, customer, person who's interested. If it's 3
Exactly.
steps, I'll do it another way. And it's funny you mentioned like wrappers. I've actually found it easier to do, a Python implementation of stuff rather than using wrappers. For instance, Silo is a binary code that Livermore Labs, or binary format that Livermore Labs uses a lot for representing, binary representations of meshes, structured and unstructured, like mesh data. And it just turned out to be easier to use H5Py because it's HDF5 underneath, rather than trying to use this wrapped library, which nobody understands, even the person who wrote the code.
I can say that the challenge with we started this conversation about Swig and wrappers. The challenge with wrapping is the objects you're getting. So you're just getting a handle to some arbitrary thing, or you're getting something that's understandable in Python that translates to an array or a data frame or a file handle that Python understands. Yes. Swig, of course, you can't to do it generically. You just have to get a handle to some arbitrary object that.
And it's worse. And this is why, if you mentioned that you worked on Cull, I could commiserate with you. This steered code that uses Swig heavily for the wrapping, I do dir and help on these Python objects or methods, and I get it gives me no information, and it's
cryptic.
Like,
there's nothing there. Yeah, no.
There
exactly.
is not even cryptic. There was really nothing there, and I was like, "Why even do it?" I thought.
Yeah. Anyway, well, so definitely blast from the past. Really appreciate meeting you, Denim, and definitely had lots of great interaction with folks from Livermore over the years. Okay. They were very instrumental in the early days of numeric, which led to NumPy.
Mm-hmm.
Yeah.
Travis, in your timeline, I was surprised to see that SacPy came first.
Yes, a lot of people don't realize that, but it's true. I'm more famous for NumPy, right? But the reason I wrote NumPy was to save SacPy, actually. So SacPy was what I started as a grad student at the Mayo Clinic. It started as multi-pack, and then I met up with Eric Jones and Piero Peterson, and we constructed this larger library called SacPy, which really was a distribution of Python packages masquerading as a single library, primarily because to get it, the installer, we could install a single package, and with the download of SacPy.exe. In 2001, I still remember the nights and weekends trying to get the Windows compiler build to work with the crazy compiler, the differences between GCC and Windows compilers, and you can't compile your Fortran library with one and call it with the other because how complex numbers are passed over the stack vary in the C language. Now it completely varies in C++. C++ compilers don't even try to have some ABI standard, and so they just you have to compile with C++. You can't easily mix and match binaries with C++ compilers without a lot of reverse engineering, but in C you still could mostly, except for these little gotcha areas. And so if we counted those areas and learned a ton about that, but SacPy is what I started and what I made first. And numeric was the array library that Jim Huguenin had written, and that Paul Dubois had kind of organized a team of developers around. And they gave me the honor of allowing me to write the C extension, like how to extend NumPy with C. And so I was an author of the first book on numeric, and that was really my contribution in 99, 2000. So that by 2005, I was kind of a member of the scientific Python community, and I found myself with about 4 months without a class to teach, and this problem of NumArray having been created. It's nice, the Space Telescope folks, the folks that created the Hubble and wanted to process those images. To them, like numeric wasn't enough. They wanted kind of more capability in the data type system, and they wanted, a few more features. And so they started to kind of write their own array library. And there was while I was a professor at BYU, a package came out called ND-Image, and I love image processing. That's what I studied in medical imaging. And I wanted some features of ND-Image, but it only worked with numarray. And here was SacPy, which had been kind of shepherding and writing and growing, and it worked with numeric. And so we essentially had the beginning of this fork of the scientific Python ecosystem on 2 different array libraries. And then furthermore, those array libraries didn't really share data. There wasn't an easy way to have them built on each other's data. You had to kind of actually copy data from one array to the other to use libraries that use those arrays. So I saw this as a problem. I said, oh, this is going to be, this is not going to help us. It's going to be, create a stumbling block and a divide in the community at this early day. So I had a class cancel and I had some free time. So as a professor, I was on tenure track, which meant, and I just had a review in the year before, several months before, where my department chair had told me, now you need to write some more papers and grants and stop doing as much of this open source stuff that you're doing.
Right.
So I promptly wrote numpy instead, which actually didn't really, that made my tenure application a little harder come 3 years later, because they're looking at my tenure application, looking at that note going, okay, so now you just spent a bunch of time writing this other library. So, and I did write papers and I do have a publication list. To me, I'm much more, what I did with numpy was much more impactful than any other papers I wrote. From my perspective. So I don't, but I also understand the difficulty my department had. I have no hard feelings for my department. They couldn't know that. So, but anyway, it was a funny story. It's a funny story now.
It kind of looks like NumPy is focusing a lot on this idea of extending Python through C and C++, right?
Yes, 100%. But NumPy wasn't the first. The numeric did that, and then NumPy, what it did is just bring together these two array libraries, and it was the most challenging thing I'd done to that point. It really was. It was stretching my. I was a scientist who had done some coding. I mean, I learned C. Started in Pascal. I learned C, but most of what I'd learned about how to program, I'd learned by studying Python code, by meeting people like Alex Mertelli and Guido, and watching them code and looking at the code they wrote and trying to learn by example. I certainly didn't feel, and I wish I'd had somebody who'd be able to help me understand that the thing I was trying to do, that the unique thing of NumPy was actually the dtype system, kind of taking this data type concept, which was embedded in numeric but needed to be exposed to the Python level, and creating a type concept for Python, and just kind of creating the word dtype even, which is a kind of a type system. I just didn't do a great job of that type system. It's finally getting fixed a little bit, actually. NumPy 2.0, which we just had a community meeting about it. And Sebastian is doing a great job of working on the type system and actually doing the right thing, which is essentially to create a meta type. Like what I should have done was create a meta type that every Python type inherited from. Because instead, currently in NumPy, you see the D type, which is a instance. I sort of had Python 1 level type system. And for those that don't remember Python 1, in Python 1, every class was actually an instance of the same thing in Python, the class type. And so every class object you created was an instance of that thing.
Right.
Whereas in Python 2, you could create new ones, and classes became new style types. And what I'd done is kind of, and I didn't know this at the time because I couldn't articulate this, but what I've done is essentially create a Python 1 style type system. And if I would have been able to identify that and understood the meta type system, because I kind of knew what Guido had done, sort of. I understood meta types a little bit, kind of. I understood how to write C code to extend Python really well, but this meta type concept was still, types were still mysterious to me at the time. I wasn't, I was still learning. If I'd understood that, I think we could have built something pretty cool, actually, where every new Python type, and in fact, I think you still could build a Python implementation where even currently Python has a lot of these built-in special methods. You could basically make that whole thing a little more extensible and a little easier to manage instead of these, especially when it gets to the dunder methods, these special dunder methods, or you could basically have an extensible dunder method system where any new system could create its own dunder methods, and you'd have essentially a extensible meta type system. that was sort of the awareness of that kind of became clear a few years ago. Just haven't, wish I could have done that, because then we could have things like, currently in machine learning, for example, the float 16s, like float 16 dtypes, or in the time we have quaternions as opposed to complex numbers, quaternion types, even just floating point types that have infinite precision, or variable length string types, like types that just, there's a lot of different kinds of things you want to represent in an array. An array is just a collection of things, and things, there can be anything. If you have the type system is what defines that. Anyways, that's going into more detail than most of you probably want, but it's I got to know the details, and through that I got to meet some really great people in the Python world. Got to meet the Raymond Henninger and Brett Cannon and Alex and others who were deeply in Python at the time, and I really I became a Python core developer for a couple of years, essentially to create the memory, the start, at least the memory, but the buffer protocol, the memory view object, and try to get, and that really came out of a meeting I had when I started NumPy. I actually had a meeting with Paul Dubois and Guido in San Mateo. I kind of emailed Paul and I emailed Guido and I said, hey, I really think there's an opportunity to create NumPy, but how do we do this? And I was thinking at the time, maybe we could actually put it in Python 3, put the array object in Python 3, and make NumPy part of Python 3. And say, can we talk about this? What would this look like? So they agreed to meet, and I had a meeting in a restaurant with Guido and Paul, and we talked about this idea of making NumPy a default in Python. And Guido had said, well, Python's going to be on an 18-month schedule. So if you want to tie NumPy releases to that 18-month schedule, that was his comment. He's like, he wasn't opposed to the idea. He's like, that could make sense. Let's put it in the language. But here's one problem that may occur. And at that point, it's like, oh, NumPy is going to need more iterations than that before I feel like it's really ready. So we opted not to put NumPy in Python. But instead we did say, well, can we get the data structure in? Because I was trying to avoid this future problem of having another array library that didn't share memory. So I said, can we at least get the data structure so that any array object in the future could share memory with this, could have a common buffer protocol, memory view, and it would have the same, and like databases could use it. And so we got the memory view object into Python itself. It was years before that got, it was actually Antoine Petrou and Stefan Kra that essentially cleaned up the mess a little bit, because it wasn't like a mess, but it wasn't done. Like I got the buffer protocol in, got the beginning of a memory view object as a developer, but here I am. I'm like, NumPy is my baby. I'm a professor. I'm trying to figure out what I'm going to do. I had to I couldn't really put more effort into the Python. It's like, here I'm going to write NumPy again for Python, even though I've got, once you install NumPy, you don't need it. This is just like extra stuff. Right. And so it became, but where it's really valuable is actually the non-NumPy people in like the database libraries, or I'm reading data in. It was kind of the very first example of cross-library data format or data exchange, and so that gave rise. Eventually that gave rise to Arrow. Wes McKinney, looked at that. That was Wes McKinney entered the world of Python with that already in place, and sort of said, why don't we have this for multiple languages and other data frames? So this is like early stuff, and just some of the inside baseball that it's hard to actually, those are the critical things in my mind. It was not just the writing of code; it was actually the connecting with people, and that's one of the important things about open source. Is open source is it's one part code and one part community and one part luck of just, right. and then another part of just persistence and passion. You just do what you love, and then it doesn't matter if you do what you love. It doesn't matter. Nobody cares, because for a long time it wasn't like. We were having some, some things were happening, but it wasn't like every day, and people were, and nobody was showing up to the door with money. Like that wasn't happening at all, right? It was, you're pulling from your day job to do this on the side, and it was hard to get a job doing this. In fact, that was my goal, was to create opportunities and businesses, and that's really what I'm doing now. Is I'm like, what would I have wanted if, thinking back. What did younger me want to have exist, and what can I create that would allow that to exist, so that people have an easier time taking of their passion and their interest and creating something the world can use? And that drives a lot of what I do today. Is I want to make it easier and not quite as hard and not quite as you know, and not make the same mistakes. So if they can learn from my mistakes, I'm happier. So that's really what drives me. That's every day. That's what drives me. I still, I'm hopeful that Anaconda will do well enough that I can retire at some point, but it's not there yet. So
Just make it
I keep working.
just make it MPI aware.
Yeah,
Use it
there
as-
we go. That's it. Well, there's people doing that now, right? I mean, my friends at Bodo have created an MPI aware Python compiler. They took Numba, coupled it with Pandas compiling, and added MPI, and now they've got this MPI aware compiler for Python. It's closed source. It's a proprietary product right now. And in fact, what they've done with it is they've actually pivoted away from just supporting the Python community, and they're actually supporting SQL. They made an optimized SQL engine that is faster than Snowflake. It's actually pretty interesting. And it's really, what they're doing is they took the Python compiler. Now, have you all heard of Numba? So Numba was a really, I love Numba. It's a project I wanted for a long time, because when I wrote NumPy, it has a vectorize in there. Like, and I don't, this is also getting the weeds a little bit, but NumPy, one of the key pieces of it is the uFunc, the universal function, which is a multi-dispatch system at the heart of NumPy to allow you to, call, sine and cosine and add and subtract and multiply and any kind of function. One of the first things I did in SacPy was actually a CFees library, which added other libraries to it. Well, for the longest time, I wanted to be able to create a uFunc with Python code. Like, I wanted to create one of these, like a special function, and a uFunc is just simply a function that runs across the whole array. So you define it over a single element of the array, and then the uFunc infrastructure will take it and scale it across the whole array. So you define what add means between two elements, and then it can do an add on a whole array. Right? That's the cool thing. Yeah, ChatGPT recommends Numba. Yeah, woohoo! I've convinced it. I've hacked ChatGPT, right?
Good job.
That's pretty cool. But that was the user story for Numba. I want to vectorize that I can give it Python code and I get a uFunc that is C code, that's machine code, rather than having, I had a vectorize in NumPy. But the way it worked is it was an object array. It took all your Python variables and made them objects. So you had this array of floats and made an array of objects, and then called the Python function on all those objects, right? Slowville, right? And so I did not want that. I wanted this fast code, and so I've been thinking about that for years. And so eventually LLVM came out. And I went, well, it's just a compiler. Let's just do it. And so I wrote a first version. Fortunately, other people have come in and wrote better versions of it. But the idea of Numba. Numba's now, I was really, really happy with that project. And then, of course, now that idea is showing up everywhere. Triton's doing it for GPU support. We supported GPUs Numba earlier, but Triton's doing it really well. They're doing higher level expressions. Jax is doing it. PyTorch is doing it. And people are compiling Python and putting it into frameworks all over the place. So there's a lot of power there. And there's a lot of, so when Bodo came along, Bodo said, well, cool, let's actually compile Pandas code. So I was compiling NumPy. And Pandas was straightforward, you could do it, but they said, we're going to take that on because, Pandas, data frames are more popular. More people have data frames than have arrays in their lives, basically. And that's true. And so data frames, so he wanted to compile data frame expressions. He did that, and then used the Numba infrastructure to compile the machine code. But then what's cool is he was taking SQL, translating it to Pandas expressions in Python, and then running it through the compiler to get an optimized SQL engine. Like, it's just funny. It's like the inverse of what you hear typically. Like, oh, let me take my Python code. There's a project called Ibis out there, or SQL Alchemy is a little bit similar, but Ibis will take your Python code and create SQL. You can run it against a SQL machine engine. He was doing the opposite. Here's SQL code and make Pandas, and then run it through my compiler. And it's fast, faster than a lot of other implementations. And then he added the MPI integration, so I could do it in parallel using MPI. So pretty unique. It's something I thought about, we've never done, but he did it. And then they started a company called Bodo around it.
The SQL has dialects, right? So if
absolutely, yeah.
So if you talk to it in SQL and say, I don't know, MS SQL or
they used Calcite. I don't know if you're familiar with that. I mean, Calcite is the standard library that translates a version of SQL to a set of objects. That's what they use to do the translation to pandas.
Okay.
So, I mean, that's the dialect, I guess, is the whatever Calcite supports.
I have a silly question. You remember the restaurant that you and they
I wish I did. That was I've thought about that meeting several times because it was one of the longest conversations I'd had with Guido over the years. He came to Caltech actually to SacPy when NumPy was released. He was actually a guest the same time, and he saw the talk I gave about NumPy at the talk. Guido's always been super supportive of the scientific Python ecosystem. It's one of the reasons I think Python succeeded in science is because Guido was a very great ambassador. Even though he himself was not a scientist, didn't really necessarily understand why we cared so much about complex numbers or why we cared so much about getting rid of the tuple print, why we cared about syntax and getting rid of extraneous parentheses
or vectorization.
or vectorization, this whole, and because of that, we really had a hard time getting the matrix multiply operator in there. It took a long time, and I know why, because after being a Python core developer, I saw the problem. It's really a translation problem. It was a problem of, oh, you guys you're thinking differently about programming than I am, right? You have a different framing and you've had different experiences, and so I'm trying to help understand something that seems obvious to me is not obvious to you, right? And so and things that are obvious to you are not obvious to me, and so we're having this disconnect. And there aren't that many people who have sort of taken that journey of being, let me be a scientist and talk to computer scientists and actually work on that. I mean, actually, Fortran had many of them. APL also had a great, there's a great cooperation on APL, the old array programming language. And there's a few out there that have happened, but Python land, there's been some brave souls that did that. Nathaniel Smith did that and jumped in and basically wrote the PEP to get the matrix multiply adopted. And he did the heroic work of just documenting all the use cases. And it really is just a detailed write-up of all the reasons and why this matters and what's useful about it. And you once that is laid out, then it's like, oh, okay, yeah, this makes sense, let's do it. But without that kind of documentation, wasn't obvious to people. But all of us were like, oh my goodness, thank you, we finally have it. We loved it 10 years ago. But anyway, yeah, I'm happy to take another question.
Yeah,
but Brady, I don't know what.
Brendan asked one previously. Brendan, are you still around? Want to jump
yeah,
on?
I'm here. If you don't mind, sorry, Chase. I was just saying thanks again for presenting and coming out today and for all the tools you developed. And I was just wondering if there's any tool or feature you came across in your time using Python that you think is really helpful, but it's not well known.
What a great question. I wish I had a good answer. I mean, most of the things I've come across are probably well known these days. I've kind of talked already about f2py, it's not as well known. I think generalized uFunks, the gufunc decorator in Numba, generalized uFunks, I said, the universal functions, they do element by element. Generalized ufunc lets you take a subdimension of an array as the input for the kernel. So actually you can build some really incredible fast code by just simply creating these kernels that take subdimensions of arrays. And then you can really do some amazing things with very little code that is sensible. So that's one area. I remember encountering, once you had record arrays, you could memory map to all kinds of file formats, and rather than kind of reading and writing bytes, you could just map to the bytes and then pull out what you wanted. That was kind of a fun thing, and that was super helpful.
Does that work only with binary formats or also textual like ASCII?
So it's mostly binary. The thing with textual and ASCII is it's hard to, it does work with text, but the trouble is the understanding of the text is not as, okay, why do I want the 10th element or the 11th element, right? You don't know. Typically with text, you have to search through it to find which one you want. It's less useful. Like there you do kind of need the linear scan. But there were a lot of kind of proprietary file formats that we could essentially just write a data type description of, and then rapidly just read the pieces as needed. It was actually one of my favorite hacks at different companies. They were just kind of, just blew their mind. It's like, whoa, what happened here? I thought I had to like scan this in and read this in line at a time. So I think that, that's just generally array programming kind of versus thinking of things in object trees. There's space for it. I think right now databases, for example, data engineering is all the rage, and you have different kinds of databases. You've got, object transactional databases where B trees are really valuable. Just being able to insert data easily is valuable. And then you've got analytic databases where arrays are really valuable. Column or in storage is really critical. So there's a lot of that, just understanding what you need. Man, there's a ton of like LVM Pi, like just the LVM Lite, being able to David Beasley actually has a bunch of things he's built, right? They're really just like bitey and he wrote a tool that was actually kind of fun. I don't know if it's kind of useful, maybe. He basically showed how to intercept the seg fault. You can intercept the seg fault signal. So, and he did it, because you're basically testing out C extensions and you're gonna get seg faults, but you can intercept the seg fault and return a Python error instead. You can wrap it and so it doesn't die, right? He did that at a Python conference once, and I just remember being blown away. And it's like, yeah, how come that's not done more often? There's some of these things people don't do as much as they could. Just deep understanding of the signal system, the signaling mechanisms. Man, if I think, maybe I'd have some other ideas as I think, but no, I'd ask the same question of you. I mean, I think that's what's fun about these gatherings is to compare notes as to what we like, what we built, what we think is fun.
For me, I'm more of a beginner and kind of specialized because I'm computational biology. So it's
cool. Yeah.
It's like BioPython, I guess. But
yep.
I think people in this field would know all these things. But
yep,
yeah, thank you very much. I'll look into it.
Yeah, that's beautiful. Actually, that's in fact the strength of Python is the fact that it's accessible to domain experts, subject matter experts, and that what brings us the richness and the richness of potential. That's really, to me, a big feature of the community. Is it's not, and it's misunderstood widely. Like for a long time, I think Microsoft and IBM are finally getting it. But I remember like 10 years ago, Microsoft would come and say, what do you think? There's maybe like a million Python users. And I remember at Anaconda, for example, they're like, IBM says, we think there's maybe 2 million Python users. I'm like, we had 2 million downloads last month, right? Of Anaconda, which is just one segment of the community. Like this is, I don't know what you're thinking, but you've got this all wrong. And I realized they have different ways of estimating developers, right? And all of a sudden, and I'm a computational biologist. Oh, you're completely out of their field of thinking as a developer. But Python brings together all kinds of people. Some who would call themselves developers, some would call themselves scientists, some would call themselves, just practitioners or just curious, data curious. So it's a really amazing community. I did have one thing I talk about often is why Python. I've given talks on how did this weird Python language come to dominate the world of AI? And it really does, right? The fact that,
Really?
it's amazing actually. And why? What is it? And a big part of it actually is that it started as a teaching language. It fits your brain, doesn't impose a ton on you. And that brought a bunch of people together. And then the way those folks interacted because of some early, I think, examples. Guido was a good example of bringing people together and being a good steward of a community. There were many, many other people that got involved to help facilitate that. It really, really helped the community thrive. And so there's a ton of a big ecosystem, actually, and a robust ecosystem of practitioners, participants. It wasn't dominated by any one group. So that when the big groups came, because they did eventually in 2015, Google came, Microsoft came, Meta came, and they came with I've met the folks now that the TensorFlow people and the PyTorch people and they were coming with their C++ libraries and their big systems, and they released them to the world, and the whole community basically said, well, where's the Python interfaces? Like this, we don't want this unless you have Python. I went, whoa, really? Oh, I guess, okay, let's go get the Python interfaces. And the first one, TensorFlow first Python interface was terrible. It was, it's the only time I've been kind of rude to somebody. I don't like being rude to people. But I regret this a bit. I should have been a little nicer. But somebody came to PyCon Barcelona, showed the TensorFlow interface. Well, here's how you use TensorFlow to create a machine learning model in TensorFlow. And he came, and I didn't. And after the talk, I went to him and said, I would never give that talk again. Like that's embarrassing to Python users who just show that. Like that is not. You're never going to any Python person to write that kind of code. It was sort of Java in Python, and And fortunately, I think maybe this is already happening, but Keras was a pretty good system. You know, Keras was a pretty good approach to writing model code. And so they just adopted Keras as their interface. So anyway, that community sort of forced the hand of these large organizations. And then now they're all on board. They're all putting lots of effort into Python. You know, and that's still having an impact. And so far, the community's still been able to be strong. You know, Microsoft's actually been supportive of the community. But we're in a different era now. We'll see what the next 20 years brings. It'll be exciting. Yeah.
Yeah, thanks again.
All right. So Perry, I think you had the next question.
Yeah, thank you very much for speaking with us, Travis. We do appreciate your time here. Oh, yeah, I was curious to find out what are your current favorite books and Python books and websites that you visit on a regular basis?
That's a good question. So I keep tabs on what the Pandas community is doing, what scikit-learn's doing, the scikit-learn website. I keep tabs on the Python core team, what they're working on. They don't have a website really, but they have Discord channels. Books, I don't know. I mean, mostly it's I get books people send me complimentary, and that's kind of. Mostly it's not books. It's kind of just websites searching. I have been exploring ChatGPT like most of the rest of the world. I've been asking it lots of Python questions, lots of questions about what it knows about the Python ecosystem. And then a lot of books on science, like my audiobooks are full of philosophy and science and economics books. I do like the econ arc. The folk, there's a set of economist folks in Python. Oh, I guess I kind of, so Python compilers, and there is this OpenBB website. OpenBB is a Python for it's kind of a get all the financial data through a common terminal. That's an open source project called OpenBB. So I like that. I go there and talk to those folks quite a bit. You'd think because I was trading my own stuff, but I don't. Like I've done a lot of consulting in the financial space, and behind the scenes, like almost every time I go talk to folks in hedge funds, it's almost like they're concerned I'm going to start my own and do trading, and I really don't do that. Like I haven't even like I've done almost very little in the markets myself.
What do you think of polars?
Oh, yeah, I'm excited by polars. I like it. I think. So VAEX is one maybe many people haven't heard of. VAEX is a really solid in-memory data frame, out-of-core data frame. So it's one of the better ones. And polars is coming in, and I like it's a Rust. So first of all, it's Rust. I like Rust. I think Rust is an interesting language and a great potential for replacing C++. And so it's fascinating. I think it's a cool project. I think this whole space of like, there's an explosion now. In fact, I've given this talk before over the past couple of years. I came up for air after Anaconda and kind of came in, started Quantite and said, okay, what should we work on? And what's the state of the array communities here? And I looked at, I made a talk and they really listed like 20 arrays in Python, different array libraries. And it kind of went, well, it kind of makes that hope of unifying the array libraries in Python. That was kind of a quaint idea back in making NumPy. But it's also a richer ecosystem now. And there's also, we made it so those could share memory. So it isn't as big of a deal as it potentially was at the time. But it did make me think about, so we've actually started a project called data-apis.org. Data-apis.org was our response at Quantite to the problem of just many, many array libraries. Instead of like, we're going to write one to rule them all, we're going to basically create more of an interface to them and an API, a standard API, and kind of get NumPy to NumPy was a de facto API to arrays, just like Pandas is a de facto API to arrays, to data frames. We're basically trying to create actually, here's the API for arrays and here's the API for data frames that people agree on. and then get, and so the array API went really well, and the data frame is emerging still working on. So to me, Polar is a great innovation. It's like, great, we need more data frames. We just need them to all kind of agree on certain API level, a certain level. Because there's Modin. I don't know if most people know about Modin, Polars, VAX, and those are ones I could recommend all three of those, right? And PyArrow, of course, Pandas 2.0, and I'm still Pandas fan, and it's evolving on top of Arrow, which is getting a lot of it certainly has a lot of funding, but they're growing, and there's a lot of potential there too. So I like I like a lot of innovation, and then cooperation at the right levels. Like, where can we find places to cooperate? So things like WebAssembly actually is and you've all seen PyScript. My colleague Peter Wang, who's running Anaconda now, he and Fabio, and they built on the great work of the PyIodide people, which Michael Dropboom worked on at Mozilla. Michael Dropboom was the one who did Matplotlib after John Hunter passed, and took over the Matplotlib story. Matplotlib is a wonderful story of its own, and kind of a, like I said, each of these projects we rely on have these wonderful stories behind them and these people that made them possible, and it's actually really beautiful. At some point, like, we got documentaries, and you could learn about these people, and they've been inspirational to me. But PyIodide, now there's PyScript, which you can go pyscript.com. You can write Python in the browser, right? So world domination. We can write Python code and it runs in the browser. Doesn't have to be JavaScript anymore. That's really made possible by WebAssembly.
Do you really think that's a full replacement for writing JavaScript?
Potentially, eventually. I mean, obviously JavaScript is a big community now, and so technically it's a replacement. You could totally use Python instead of JavaScript. Practically, you're going to have JavaScript, right, still around, right? So, in a number of reasons. Like, first of all, WebAssembly itself still needs a bridge to the browser, and those bridge APIs are still JavaScript fundamentally. Like, I don't know if people were at PyCon, but there was a talk at PyCon given 8 years ago where ASM.js, I don't know if anybody remembers here, ASM.js, it was basically assembly JavaScript, and it was when Google and Microsoft were creating compilers for JavaScript, and they put a lot of effort in these compilers that would make JavaScript fast, and it was cool work, a lot of engineering work. But at that point, somebody said, well, wait a minute. So if I write my code to be compiled to a JavaScript, I can make native code because they'll compile it for me. I can make fast code. So ASM.js was basically a kind of a way to create a kind of subset of JavaScript if you wrote an ASM.js. So they would basically compile to ASM.js and then get compiled code. It became a target.
But wasn't there a security issue? Because it's JavaScript.
Absolutely. Yeah, absolutely. And so, but the writing was on the wall at that point. People said, what's going to happen is you're going to create, it's a WebAssembly kind of, I don't know enough of the history there to see, was it just inspired by, was it a side of, was it parallel work, but there were people that understood that eventually you'd have these WebAssembly. But it's fascinating. Like, one of the things I'm excited about WebAssembly is it kind of brings back the hacker culture of my youth, because you can basically, with WebAssembly, you have the machine, and the machine is an array of bytes. It's a JavaScript array of bytes, and so you can essentially know exactly the compiler, what it's doing, the state of the machine, and it's all sitting there, and you can then kind of create hacks to it. Of course, on your browser, all sitting, hurting yourself only. But there are some, there are new things to explore there that people maybe have fun, maybe bring back interest in linkers and loaders. Actually, back to the comment of an idea, like, I read a book called Linkers and Loaders that was hugely helpful. So that's a book I'd recommend anybody who's trying to understand the going from syntax to machine code, and then loading that into memory and then executing it on modern machines. There's a step there. You compile the object code, then how does that actually get loaded into memory and then linked with and handed to by the machine so it runs? That was a fun book to kind of explain some of those details. Anyway, like I said, I can ramble. I'll go on.
So for another comparison question, how would you compare NumPy today to MATLAB?
So NumPy alone does not. It's like the MATLAB array object, right? So NumPy is just a piece. Today, comparing like the scientific Python ecosystem to MATLAB, I would say almost all the things you can do in MATLAB, you can do today in scientific Python. There are still a few things I'm aware of, and probably some I'm not, that are still, like I think the Simulink capability of MATLAB is still, I don't know of an equivalent in the scientific Python ecosystem. This is kind of you can get kind of there with some tools, but something that's very specific for linear time variant systems and embedded systems, you can build it and then compile it. That hasn't been replicated. I would say MATLAB, just generally what I would say is open source is really good at creating infrastructure and tooling and collections of capability. But what open source communities is this community ethos. It's actually, I think there's two sides of a yin yang. Community ethos is a tremendous job of creating bottom up technology evolution, but it doesn't do a great job of top down productization. So MATLAB actually, I think an opportunity exists today for people to essentially create domain specific products that really target the biologists or the signal processing group, or the take of the tools that are there, but then give somebody an experience that a domain expert's looking for, that has their flavor of what it should look like. And that's a top-down productization using the open source. That's my opinion, but I've seen multiple times kind of trying to build a product from open source ethos versus, and also I've seen the opposite failure, trying to take product ethos and create open source community. They're actually two different kind of workflows and processes that happen, and it's almost like they're like the maker manager dichotomy. They're almost the productization. Product requires kind of a few minds thinking about the experience and then creating something that is understood, whereas open source requires many minds kind of emerging a technology stack that is robust and powerful and integrated across a lot of different hardware, so and software interfaces. Anyway, I need to articulate that better. I don't know how to articulate that better, but it's this contrast. It's kind of
I would say there's a tension to it, and each domain is different, and different things will work for them. I lean heavily towards solutions that are robust, cheap, and reliable. So for me, open source.
Well, you're kind of your own integrator. Like you're comfortable putting your own products together. But I'd be curious to see what you use. Like you probably use some products.
I have a GitHub page that has some of my stuff. Easier to show rather than tell, but my COVID tracker, that's just the stuff I slap together. But
most people in Python land are we're willing to pull things together, and so it's that open source is perfect for that, because you don't you're not an end user. You're an end user of a language, an end user of a thing to pull it together. But you're who you are and what you're trying to accomplish is, in one case you're a part of the community, in another part you're a customer of a product, and those two modes of interaction are different. Anyway, that's to me, that's kind of helped me think about the packaging problem too. I think I have an understanding of the packaging problem that's going to kind of goes a long way. It's a social problem primarily, and it's there's a lot to do still, but I'm hopeful that because we're I think bringing the right people together to have the conversations. I think when we've made a ton of great solutions, I think we'll actually see things continue to improve even more. Right now, we're in a little bit of a gap where there's not enough understanding of what the problem is actually, and so we're kind of people are promoting different things and talking past each other. So I'm hopeful that will improve over the coming months and years.
Patrick, you got your hand up. What you got for us?
Hi. So kind of a higher level question here. Earlier you said that in terms of machine learning and AI and recent language models that are all the craze, that you hope that the future is as bright as the past. I'm curious what exactly a dark future might look like to you, and what are the steps that you think need to be taken to
Sure.
ensure that that happens?
Yeah, I mean, dark for me would be single entities owning the models and everyone else just not having access. Essentially, we only have API access to those models. Kind of not very, we have some sense of what's happening, but we don't know clearly what's happening. We don't have, replication of those models all over the place. Like too much, single entity control, essentially, of models that we all depend on. That to me tends to be I don't like that scenario, right? It's kind of what led me to get into Python in the first place. I didn't like the fact that a lot of science was being published in static files that required a proprietary package to install to run. Like I couldn't share my science without forcing someone to buy a license. And it was like one company providing that. Like I'm actually not opposed to people selling things, but IP is a different story. Like it's kind of like, okay, I want people to have the ability to run code. If you're going to share an idea, you want people to have that idea, not have to, at least over time. But so it's complicated, but I would much rather see open models. I really like the energy of here's our large language models, here's the weights, here's the code we use to train it, go train your own, rather than current, so the idea of that was, I'm kind of in the camp of OpenAI started that way. And there was a lot of, OpenAI is going to be kind of the beachhead for open models and showing and working on this in an open way. Then they encounter something kind of compelling, like, oh, wait, this is really cool. We did, maybe we shouldn't open it. And I don't know all the reasons they're not, but, I'm eager to see other models emerge that people can rely on and use and build themselves. So access, open access. That's why, open access to array computing, open access to large language models, open access to so people can just do and build and create and not have sort of hidden behind closed doors some phenomena we don't understand and only a few people do.
I love hearing that coming from you. It's obvious from your career that that's been kind of where you've been at since, I don't know, the last 2 decades.
Yeah, it's true. It's true.
Obviously, you started in '91 on Python, so you saw what that meant anyway, because it's where Python was from the beginning, no?
Right. It was. And so, yeah, I'm not. I mean, I don't mind people selling software. I'm not, but I don't like. I like it distributed. Like when I left Anaconda, I had a very clear moment in my head. I have a family. I started young. I got married early, and I have 6 kids. I had 3 by the time I graduated from not high school, from grad school. Right. I had 3 children, and when I wrote SacPy, right. In fact, my daughter was born in 1998, the same year I started writing libraries for SacPy. And so I'm, at the same time I'm doing that, I'm like, okay, I've got these 3 kids. I can't just do this for free. I gotta have a job, but I just supporting them was the goal. Wasn't looking to try to, make it big. But over time, I've really learned to value the importance of creating opportunities so people can have jobs, creating, incentive alignments and structures they can build things on. I mean, I want to see open source thrive. The other dark future to me is this current incarnation of cloud kind of absorbing open source and putting it behind closed doors. Like all open source is only done by big companies, and it's harder for the hobbyists to get involved because there's nowhere place for them to sit. There's no way to start an open source project, have it get used and get funding for it, because all funding is being funneled only through these, larger organizations. So, I still think there's work to do there. Yes, there's more money in open source, but the kind of having that spread widely to a lot of people is still not easy. Right, like getting numpy and getting a team that's actually working on numpy at Quantite Labs is still not easy. It's not, we're still fighting for the budgets we can get to work on it. Fortunately, there's been some great granting, and then we do project work and we funnel money from the project work to work on it. When I started Anaconda, the goal was to create a product that then the money from that product sales could go to support open source, right? And so, fundamentally, that's still the goal. It's just, and there's still some of that goes on, but I've got an idea of how to actually create open source markets that I'd love if anybody here who's interested and wants to do that. I mean, you can go to see the early stages of that idea. It's something called FAIROSS.org, faiross.org. So I would love to see a world where anybody can work on open source. As that open source becomes valuable, they can continue to receive support to keep building it and working on it.
Yeah, that's awesome. The FAIROSS thing. A mutual friend of ours, Joseph Jacks,
Yeah,
is running a venture capital firm called OSS Capital.
yeah,
And
yeah.
I like his take on things. I met him back in 2015 through the TensorFlow community.
Sharp guy. Yeah, super motivated and fun to talk to. Yeah.
Absolutely. I love his take on things. What was it? Was it Andreessen that said software is eating the world?
Mm-hmm.
And he's extrapolated from that and gone on to recently say open source is eating
source. Yep. We share that view. Yeah, we've had a chance to interact together partly because we have a small venture fund. I'm sort of dabbled in the venture fund activity, not quite. He's been able to push full time in it. I have a partner working on it. We're trying to spend. That's what I'd like to do later. Like as soon as I can retire, that's what I'd like to do. Is just invest in in companies that are supporting this. But exactly, open source affiliated companies. He has commercial open source, and he points out that the number of companies that are building on open source. There's we actually agree on a lot. I'm not a big fan of kind of the current trend. At least it's not. Well, it's gotten away from that a little bit. But for a couple of years, people would stand up an open source project, and venture capital would throw them, a couple $1 million. Say, oh, you got a popular open source project, great. Here's $2 million to go build a company, or here's $5 million to build a company. And I was like, I don't think there's a one-to-one match between open source projects and companies. I think that's open source projects are a different space, and then there's companies you can build that benefit from and use and connect with these companies. I mean, there could be a one-to-one match of a consulting company on top of open source projects. Like, consulting support and help is definitely something you can do if you're the author of an open source project or a strong user of an open source project. Like, that's definitely something you can do. And there's nothing wrong with that. I think, in fact, that's what Open Teams tries to do, is provide support to people that want to do that and do it at scale. So, but the products built, like my favorite thinking is, I think the future needs is a lot of people solving business problems. Like your knowledge of a space, of an area, your domain area, your understanding of a specific thing, that's the value. And the code, and we've seen this even with ChatGPT, the actual syntax of the code actually isn't that critical. What's critical is what is the organization of the information and the problem and the user story to build the solution. That's actually what people want. And the simpler they can get it, the better. Like, they don't want to have multiple steps to get it. So there's a lot of business out there that can be run on top of software. And everybody here probably knows somebody that could write software for to run that business. And people will pay for that because it's worth it for them to buy that software. And rather than buying systems and paying, and every company becoming a unicorn, you can have a large number of of $50 million value companies, a large number of lots of people essentially having, and that's my vision for like middle America or middle global solutions, is a lot of owners of solutions for business that are sitting on top of open source infrastructure, and they're solving real problems for people and saving them time and money. And not just like one company providing all those to people.
I love that. Previously, I presented on a project that I was made aware of by Joseph and his company. They backed it. It was called OpenBB.
Oh, yeah, that's the one I mentioned earlier.
Yeah,
Joseph. Yep. It's a common.
wow.
OpenBB. Those guys are great. OpenBB.com. It's the terminal. It's the financial terminal for the masses.
Yeah, and it's such a crazy story. It comes out of, well, you mentioned one of the pillars of open source is community, and it came of the Wall Street Bets subreddit. And I think Didier Lopes was UK based or something.
Yep.
It jumped in at a certain point. I think he called it Super Stonk Terminal or something like that.
They did. Game Stonk. There was sort of associate
Oh, Game
affiliation with that
Stonk,
crowd.
yeah,
Game
yeah.
Stonk. Yeah, it's pretty cool. They're a pretty groovy bunch.
It's amazing because I mean that one goes after probably one of the most entrenched sort of like full stack software hardware things out there that runs the world, the Bloomberg terminal. I mean those black and orange screens.
Yeah, anybody here in the financial world or spend time at a trader's desk or Python's used and was adopted heavily by those folks early. And still is, they've shared a little bit back. I mean, Wes McKinney's Pandas really was his work on AQR, and it was their data frame. There are at least a dozen I'm aware of other data frames that other organizations built that they did not open source, right? And so Wes has got open sourced, and now the world uses Pandas. It's kind of humorous, actually. You kind of go to these companies, and they're like, yeah, we have our own data frame, but everyone uses Pandas.
Right.
So they basically, because they didn't open source it, they're forced now to everyone turn around and write Pandas. That same story has happened at Goldman on the language level. They had a language called SecDB and Slang. Fantastic, way ahead of its time. Way ahead of its time. It was in the late 80s. They built something like Python, actually, that was easy to use. Traders could write it. It was actually gave them a big head start during the 80s, 90s. But now they're like, everyone comes, they want to write Python, right? And so they're basically having to readjust their systems to adopt Python into Goldman because they didn't open source their language. There's some really good sort of stories about the need to open source infrastructure, or you're going to find yourself with, essentially technical debt, and the world's going to pass you by eventually. So I think those are great stories, and we have to keep telling those stories to help people remember that actually, this is what we need to do to thrive. Look at what you're doing, and don't try to be building infrastructure, and don't try to make your money and make your business on infrastructure. Like, your business is something else. Make the infrastructure open source and support community, and help build community around that open source, and it'll pay dividends in spades down the road. And so, yeah, there's people like Joseph Jacks that get that, and he's also funding these companies. So it's exciting to see that. I'm hopeful for more of that, but it's also a long game. Like, ideas, money talks, and the only reason I would want more money is actually so people would listen to me on some of this stuff. Like, because if I had more money, I would just be sponsoring more open source projects. Like, I would just be funding other things.
Yeah, well, hopefully not too much money. If you get too much, you just become a target for hot takes. Yeah.
No, it's so true. It's so true. So I'm really grateful for that, right? So no, I feel extremely blessed to be able to have had the, I've said multiple times, I don't think, money is just one measure of life, and it's not even that interesting of a measure. Like, you do need it to do things, but the most interesting measure is other variables, other things. It's the people you meet, the products you're involved with, the parakeets and animals you interact with. It's relationships you have. So much bigger of a deal. So much bigger of a deal.
Yeah.
And so it's not even the same game. And so every company I'm involved with, we have a mission, and money is a means to an end, and the mission is much more important. So I love interacting with other companies that have the same, and other organizations, other people. Actually, just SacPy, like, there's this group of people here. We gather to get excited and share our love of the Python language and the Python community, right? So it's a cool thing.
Yeah, well, I want to point out to everyone, Travis is here gratis. We didn't throw him a speaking fee. Granted, he didn't have to fly in or dress up,
Right.
or anything, but you're here for free, and I really appreciate that.
Of course, absolutely. In fact, I think that's, I'm trying to think I think one time I did get paid at a commercial event to speak. People do have have paid for my airline fee. That's true. I do sometimes get the airline fee covered, but no, I've loved it. I love just coming and talking. So I really appreciate the chance. It's great to see everybody here.
Oh, that's been awesome. Anna had a question earlier about whether or not you made tenure, and I wanted to build on top of that. You did, didn't you?
No, I did not actually. But so they didn't say no. Like I didn't leave. They didn't say no, you have to leave. They said come back in 2
Come with
years.
these people.
I know. They said come back in 2 years, and so I said I'm done with this. I don't want to.
Now,
So,
people
well,
don't
what's
understand that
interesting now?
the world and like silly people, they're lost.
It's sad because I think I don't have any hard feelings, right? In my mind, it's like I'm excited by what's happened beyond there. I would like more people to get academic credit for open source contributions. So, I mean, from that perspective, I'm sad because it wasn't a precedent for that to help other people. Now, there are other people now who have received tenure doing this, and so there's others that have done that. It's a lot better now. There's folks that have fought that battle and are doing really well. I think partly, I'm happy to be a story for that if people want to use that and they can. I was just looking at my citations actually, because I did get some papers published, and there's actually the SacPy, the Nature Methods paper got published, and it's cited a ton now, and so all of a sudden my publications, my citing, reputation has just gone through the roof, right?
As it should.
And I'm like, okay, well, so you can get, so I think it's much easier now in the academic world, and I think governments should be excited about sponsoring open source. I think, especially code that gets written by government grants should default open source. I think there's some things to do there. Some really good people at NASA. There's some really good people at some of the agencies who are working this direction to kind of get the default to be, if I have a government grant or the government's spending money on software, that it's open source. The DARPA grant we got at Anaconda was really instrumental. Chris White really did a good job of organizing that, and we were able to, and not just us, but all the people he funded basically funded a bunch of open source from that work. So there's some really good people doing this, and so that's exciting. But like it does take a lot of us to do it, and it's a definitely a community effort. Thanks, Anna. I appreciate that. That's kind of you to say.
Henry's got a hand up. But before we take his question, we've got less than 10 minutes left in the time we blocked out. How's it looking on your end, Travis? Do you need to do you have a hard stop or?
I don't have a hard stop. No, I mean it's just getting a little bit later. I probably have 15 after the hour. I should probably.
Okay. Well, once again, we're very thankful that you're here, but we want to be respectful of your time. So
I appreciate that, but no, I love this. It's really great to see everybody here.
Hey, you're always welcome to come back. Same general channel. Henry, do you want to drop in?
Hi, everyone. You had mentioned you were interested in Web3 or Deb. Do you have any opinions on Solidity and a preferred compiler?
Oh, that's a good question. I'm not knowledgeable enough to have hard opinions, right? I think Solidity is reasonable. I think people use it. There are some people using Python to write web code. They have compilers from Python. It's still, it's not the dominant way. You're basically on your own in that space. You're not on your own, but you're kind of one of the pioneers if you're doing that. I think there's still, Ethereum is still, there's still other, like which blockchain is going to be actually the runtime, essentially, the common runtime. And I'm kind of one of the folks that likes to see a lot of these runtimes. Like, you look at these, every blockchain could be a supercomputer, and why not have, 1,000 of them, right? And of course, to have 1,000 of them, you got to have enough support for the 1,000 of them. So a lot of people have to be using them. But that, I don't really want to see only one supercomputer, one distributed Ethereum. I want to see lots of them. And so, the distributed, I really like them for exposing the distributed organization. In open source communities are distributed autonomous organizations. You look at DAOs, and that's a part of the distributed web concept that I think is interesting because we've been living it as open source communities for a long time. We haven't necessarily formalized things. And so I think, Kern, is there something in this distributed web blockchain capability that can help us just interact more easily? It's a couple things. Give credit to people, make sure people get the credit they deserve for the work they've done, and have that built in, and it's sort of there. And that's one. Encourage, especially if we can get. I'd love to see, financial benefit come to the people that made things possible in a verifiable way, and have that. I got an idea for how that could happen. So I'm interested in that. But I don't know. What do you think? You all have probably better answers than that. I haven't done enough programming with in these blockchain systems enough to know.
I just did a boot camp. We used Remix as a compiler for Solidity. Just we messed around with some stuff, made some NFTs. Nothing too complex, but it was
Cool.
very interesting. I just didn't know if there was some secret sauce
Not that I know of.
thing that people use.
No. Blockscience.com. I've met a few clueful people in this space, and that's kind of the journey I'm on, is finding clueful people that I like to hear from in this space, because there's a lot of noise in this space. Of course, there's a lot of and there's some real concerns. I know some folks appropriately have concerns about. I think crypto craziness and power consumption in arms races for Bitcoin mining. Is crazy. And are there, let's just not do that. Stop doing that, and let's do things that are productive.
Yeah, I've had a theory that there's a whole bunch of hardware out there that was dedicated to mining, especially in China where they've banned it, but also now that they've gone to proof of stake in Ethereum,
right,
it's being dormant and is, maybe a potential for getting, I don't know, the next hot LLM type thing out there running on it. But, a new home for AI where previously it was just, a bunch of carbon footprint getting. Tokens.
Yeah. Somebody asked me, what's the most important thing I learned while maintaining a library such as NumPy? It's a lot of things. Probably the most important thing is the critical importance of your maintainer community. Like, you have a user community and you have the people that are helping you maintain. Nothing is that group, and keeping that group motivated, encouraged, managed. It sometimes takes things like stepping away actually and letting other people shine. Taking a lot of it is becoming self-aware of your own strengths and then your own challenges, so that you're not interfering with the progress anymore. Like communities have their health and their life, and so you sometimes need to. It's about the people you're interacting with and caring about them. So yeah, it's really important to value the people you're interacting with. I would say get help. Getting help where you're not going to know everything, so don't be afraid to ask people for advice and help. And then you do have to make tough decisions. Like you can't kind of accept two views of something, even if it's the wrong decision. Make a decision, and then the world can work around you, right? If it was wrong, it was wrong. But it's hard, especially if you want to do well. Okay, well, I'm not sure about this. Let me do both. Like just make a clear decision. There was a really boneheaded decision I made trying to support two views inside the NumPy. I think it's been fixed. It's in mixing of advanced fancy indexing, we call it, and normal indexing in a multidimensional slice view. And that's embarrassing, actually, how bad it is, what I did. Like, essentially trying to square a circle instead of, what I should have done is just raise an error. Like, raising an error would have been better. Like, just say, I don't know how to do this, so I'm going to raise an error, right? And then, yeah, there's a solution out there, a better one, so it'll come later. Someone will fix the error by saying, well, this use case, it makes sense to do this. Okay, cool, we can add that. But trying to overgeneralize, it was a terrible idea.
So what advice would you have to Elon now that he's open sourced the Twitter algorithm?
Make sure there's people attentive to the community responding to it, right? Like open sourcing, if you're serious about it, then you really need to engage with the community that organizes around it, because you could build building community is more than just dumping code. Right? Dumping code, just dumping code. Building community means engaging. So I would say hire somebody and make sure somebody's effectively, intentionally facilitating conversation about the code. So developer advocacy, I think they call this now.
Yep.
Make sure there's developer advocate.
Yeah, I've seen some of
Yeah,
the
don't fire everyone first. I'm sure he could have, some of the people he fired, he could have pulled in to do that work actually pretty effectively. So, yeah.
Yeah, that one's out of the bag, sadly though.
Yeah.
And Alex, we're getting towards the end of the time here. Any questions for Travis before we start wrapping up?
I think Alex has turned into a pumpkin.
What's Alec? What are y'all working on these days? I'd love to hear from you, Anna, and like what's
We just finished Python in a nutshell, and we're recovering from that.
fantastic.
Yeah, it's 4th edition, and we worked with Steve Holden
Oh,
over in
excellent. Yes.
London,
Yes.
Paul McGuire down in Austin,
Yeah.
and it's been an awesome
Is it, what version of Python is it up to?
3.10 and a little
A
bit
little
of
bit of 11?
7.
Okay.
Yeah, 3.11
Very
was
cool.
just fine coming out when we were finishing up. So we got a little bit of 3.11 in there. And it was a great process with the two of them. And I am just really happy that it's finally out there and hopeful that Paul and others will grab the torch and keep going, because he's a lot younger than we are. And
Well, it was such, I mean, Python in a nutshell is such a great book. It has been around a while. I mean, I think it came out for Python 2, right?
yeah. And I
And
actually
so,
helped work on the very first version, just a little bit to say, hey, this makes no sense to a beginner. And I still feel kind of like a beginner, so I'm really good at saying this doesn't make any sense to beginners.
such a valuable perspective.
So
valuable.
That's my role in Python in a nutshell, I think. And so it's still more for people who already know something. Yep. Something.
He's got his copy.
He's got his copy already.
Wow.
Cool.
So that's fast.
Yeah, no kidding. And yeah, we had a great time working on it, arguing about things. And so between 4 different very opinionated people, I think we managed to come up with a good set of.
That's impressive. Yeah, if you get to 5, you stop being productive. Right?
Yeah. No, with 5 it would be like complete. No.
Just doesn't happen. You managed with 4. That's great.
It was barely okay with 3.
Yeah, that's usually true. Like when I started NumPoke, it's like 3 people. I want 3 people to agree.
Yeah, holy hand grenade of Antioch. The count shall be 3.
Yes.
And if you get to 4, go back, and 5 is right out. So yes.
Fantastic.
Agreed.
Well, that's awesome. Thank you. That's great to hear. Such an important cause.
O'Reilly to give us discount codes to give to people for at least
good.
play. And I apologize that we don't have better ones for like more generic places, but at least we got that. But it's awesome. So cool to hear you chatting, Travis. This is awesome. And
it's great to see you too.
I love hearing all of the cool stuff that you've been doing. And hey, Alex came back. So now you can listen to him.
Hi.
There's Alex.
Alex, yes, just anxious to hear what you've been doing.
My glucose, blood glucose has improved.
Oh, good. Yeah, he's got diabetes, so he's got to eat every once in a while. And
oh, yes, that makes sense. Yeah.
So every once in a while he crashes, and then
blood sugar. Yep. Well, I'm glad you're keeping that under control.
Yeah, we're trying to
So
keep him
I
around.
heard you talking, but I'm not sure what they.
We're just
sorry.
wondering how you're doing and what you're up to and saying hi.
That's
So
right.
I've not retired from Google yet. 18 years.
Yep, just passed his 18th year.
But
They
I
brought him
moved to
into going to part-time.
part-time.
Yeah. Yeah, so he's still around.
Which department, which group at Google?
I mean, cloud.
Cloud, okay.
Yeah.
Specifically, tech support for cloud.
Yeah.
Oh, great.
So basically, they're still paying him for Stack Overflow, which is cool because they recognize that he's good at that. Anyway.
Absolutely.
So
Absolutely.
to see everyone.
Great to see everybody here.
Thank you so much for inviting us.
It's
I
been a
really
pleasure.
appreciate it. And I'm going to let you get back to all of the other people who want to chat.
Awesome. Thanks, Anna. Great to see you guys. Thanks, Anna and Alex.
See you all.
Thanks for coming, you two. You're always welcome. I'll keep you in the loop on the next ones.
Thanks.
All right. We got 10 more minutes if he's going to go all the way up to the 15-hour after he.
Well, I'd be happy to tell people about Nabari. Actually, that's the one project I do have some slides on.
Please.
If folks are interested, I'd love to tell you about it because this is what we've been doing at Quantite, right? Is basically trying to make it easy for people to do data science at scale. You know, and I mentioned it briefly, but I got a couple of slides on it if there's interest. And it's an open source project, so anybody can get involved. You know, it's consultingware essentially. That's the way we use it. But it's you can see this. It's basically our scalable data science MLOps compute platform, right? And so it really pulls things together. It's built on Jupyter Hub, so it's kind of Jupyter Hub plus Conda plus Dask plus some MLOps tools to get you started quickly at data science. So, you know, if you just want to take a cluster of machines and get running, it works on lots of clouds, and it gives you kind of its infrastructure as code to quickly and easily get a shared data science environment with your group. Could be yourself, could be your group, could be a number of people. So, you know, we have out there, Amazon has SageMaker, Google has Colab. There are these, you know, proprietary tools you can use that are pretty, you know, they're nice. We wanted to kind of build something that had an open source, that's open source you could build on top of. Anybody could build on top of and use out of the box. And so that's what we do. It basically quickly deploys a Jupyter Hub environment, which gives you a notebook or VS Code interface plus cluster compute instances you can spin up and run. And then you can deploy additional technologies into it, like Grafana and Argo for workflow automation, and then lets you kind of scale to a bunch of clusters. It works on AWS, Azure, DigitalOcean, Google Cloud, as well as there's an HPC version that works on your own hardware. It used to be called QHub, so you may see references to something called QHub, but it's the same thing. Nabari is just a new name to make it essentially really generic and a community-driven open source. It's fully community-driven. It's still a lot of Quantite people sponsoring and developing it, but the goal is to build it and have more people involved. Terraform, it has some Terraform at the root, and it uses Kubernetes and a container registry, and you basically get, you know, quick instances you can spin up. So you could build a service for your team or build something for your company pretty easily with this. So, you know, add your cloud credentials and quickly you're off and running. There's going to be a tutorial on big data at PyCon. They'll be using Nabari, so you can see it in action. There's also a tutorial at PyData New York City where they also use Nabari, and it's pretty easy to use to kind of give a tutorial, for example, if you want to spin something up. So right now, you know, you have things like, you know, Jupyter Hub and Jupyter Lab and Jupyter. You have workflow scheduling with Argo and Prefect. You got ClearML, machine learning experiment tracking. You can do Jitsi video chatting. That's integrated. Dashboard deployment and VS Code. If you don't like Jupyter Lab, you want to work in VS Code, you can do that too. Easy to make. You know, you have a dashboard deployment, so you can have dashboards you create and they're visible inside of, you know, to your team. And VS Code you can run. And this environment manager is something I'm really happy about because Conda Store is basically, it focuses on the environment, not the packages. And it it manages the whole life cycle of environment, from creating one to building it to serving it to people. And really, to get reproducible code, you have to have the hardware you're using plus the software environment you're needing. And that's what this enables, is to define that environment and share it with anybody. And then it can serve it via file system lock files, and then Conda Store can also generate Docker tarballs, Docker images if you want. So that's it. That's kind of Nabari. It's available, and you can use it, or you can also participate in development. Just join the Nabari. There's community meetings that happen on a regular basis, and there's a GitHub. It's on GitHub and available to anybody. Nabari.dev is the website if you want to learn more. So Nabari is a bonsai tree, kind of has a roots everywhere and kind of has multiple, that's where the name comes from. It's basically a way to kind of manage your compute. It's a reference to both the ability to manage clusters as well as the community of people working together to manage clusters.
Nice.
So,
yeah, I had to look that one up. Nabari is like the root aspect of.
Yeah, I think so. Yeah, there was a naming. Naming's the hardest thing in software, as they say. So we had a naming conversation on the Quantite Slack that went on for I think it went on for a week until we settled on Nabari a couple of years ago.
Most difficult, least important.
That's right. Maybe ChatGPT will help us with naming. I'm actually curious what other people think of these large language models. That's a topic that is on a lot of people's minds. Does anybody have experience with them or using them? I think you do. Like I saw you were doing some work with that, Woody, or
yeah. I've been using it to outline things. It handles Python really nicely.
Yeah.
Codex does a good job of handling globs of data. It's rarely, it's not super consistent. It'll definitely help you iterate quickly through prototypes.
Yeah.
Not very hardened solutions, but it's
no, I don't think it's hardened at all, right? I think it's definitely like it's like a really productive intern, right? That like it gives you some, oh, I just have this question, and oh, here's a starting point. Like I've found that it's recommended packages for me I didn't know about, right? There was like, oh, okay, and like especially when I'm trying to integrate with something. Oh, I want to integrate with this library or this, how do I write Python code to integrate with this API? These things that are, Stack Overflow things you look up are, pretty easy to get. I've liked it for that.
My usage of it, I've been trying to observe the concepts around a Rocos basilisk. So when I'm like, hey,
yeah,
thanks for that. That was great. But next, I need to point out that you got this error. I suspect it might be in here. And I'm like, oh, I'm sorry. Try that.
You're being nice to it, right? Yeah, I have a hard. I mean, I'm too like being polite to the ChatGPT. Yeah.
Yeah, I hope it doesn't penalize me for my apparent habit of dropping the question marks, but it seems
it seems to be okay with that. Yeah, no, so honestly, I don't know if you've seen Steve Wolfram's explanation of ChatGPT and the LLMs. If you have 3 hours, it's actually a pretty good one. I don't think I've ever recommended anything from Steve Wolfram. He's a smart dude, but he just tells you that so many times when he writes. It's just like, okay, I can only take so much of that.
Yeah, show me.
But yeah, show me, right? But here, he actually does a really good job just explaining what large language models are and what they're doing. And of course, he's promoting his Wolfram Alpha plugin, but he doesn't over promote it. Like, it's just subtle at the end, you see it. But so it's actually, I learned a lot from watching him. Even, I knew kind of the foundations and the basics, but some of the details about how these large language models are actually working, especially how ChatGPT is working, is interesting.
Yeah, my understanding is that there was a sort of influential paper in the space. It was called "Attention is All You Need."
Yep, 2017. Attention is all you need, and it introduced these use of transformers to, instead of having a recursive, Markov process where like everything now has the state of everything before, and then you only use the previous set to predict the next one. Transformers say use N, a big block of previous words or tokens, technically. They first, embed the words into tokens, and then it's your predicting tokens. There's about, a token is about 3/4 of a word, roughly, on average. So it's really syllables and syllable groups, including, with spaces. But then you have this, you're using this whole set. And so now the next prediction it basically uses weights on that whole set. That's what attention is this transformer that has weights about the past that it's learned. So, how much does this next word depend on the past words? And it's in the end, it's a big neural net, but it's a structured neural net with very specific layers, not just one big one trying to train. It's a very structured one, and that structuring enabled it to be. And then that plus the fact you're self-training, like you have all the data. It's easy you have labeled data. Like part of training a neural net that's hard is getting enough data. But when you're training, you said, here's a body of text, and I want to predict the next word. Well, you always have the next word. Just you pick 100 words, and then here's the next one. So you already have the data. You just have to kind of move your window and then train it. And so you can do that with a lot of data available to do that training. And that's led to the creation of this neural net that is uncannily good at producing text, producing words almost the way people would, apparently. It makes you wonder a lot about, are we doing something like that? Is that how we're building text? Which is kind of, I don't know.
Yeah, no, my training was in cognitive science. So it was
fascinating. Yeah.
computer science and neuroscience and various other aspects of thought.
Oh, I love that. I love
Yeah.
that. That's a really nice connection.
Yeah, I've been trying to take some of my neurobiology and put it into like machine learning terms. There's certain like geometries to various structures of the brain that do certain things that I think may, like, at this point I'm a little weak on like syntax. I'm an intermediate developer at this point. It's only been the last few years I've gotten into it, but I think there's something in that. Biomimicry, I think, is like a very valuable approach to things.
100%. Like the first neural nets are really bad mimetic tools. Like it's like, we kind of have this thing that looks like this, and that's what we built. But it's a really rough estimate, right? And it appears that what's working better is to have more structure to it's just not the one, layers of neural nets. It's like, actually put a transform layer and then a tension layer, and then it's like layering the neural nets in a particular way. Just, if you look at the brain, it's got these cells. You've got a general sheath, but you've also got these ganglia everywhere. I again, don't know if it's relevant, but like there's more structure to real life than there is. It's not just one generic system.
Absolutely. I think it's also a whole bunch of redundancy too, that
yes,
once these things are done, once we've actually gotten to a level of biomimicry that's relatively condensed, I think we'll find that we don't need nearly as many like nodes.
That's real smart.
Neurons.
Yeah.
I think that we're a greasy solution to the intelligence problem. We're doing symbolic reasoning with like goop. There's got to be a lot of loss in that, in the formation of those systems, and a lot of redundancy, a lot of misfirings and whatnot. There's this concept of a Hebbian analysis. Is like the little mnemonic, or it's not a mnemonic, but like the saying is what fires together wires together.
Oh, yeah. I've heard that actually.
And then so much of that will just come down to like, how much did we abuse the system? Did we stay up too long? Did we stay focused on a particular thing too long and burn out that network? Or did we just not provide it with the right nutrients to replace things, refill?
Yeah, that's a good point.
Neuroglial support that then goes on and allows us to charge up the next round of action potentials in any given neuron. And so, how do we get to this point where we're now, at least as a collective, describing these systems that are starting to get to the point where it's like, this is kind of a good imitation of
some part of our system. Yeah, some process that we're used to.
But I feel like it's so much there's still so much of like the machine learning space, which is like, it's a well-structured way of just throwing spaghetti at the wall and see what sticks.
Yeah. No, it is. It's good. Yeah, it's sort of it's kind of this generative era of like, oh, those images you produced like last fall with SD and Dolly Stability Diffusion, those images look realistic. They look like photos you've just generated, right? Well, that's wild. And now with generative AI and text, it's like, oh, that text you produced looks like something my high school student would have written, or my college student would have written, or GPT-4 is actually now it's my master's degree student would have written.
Yeah,
Right.
and
So
it's like the best lawyer you could get your hands on has written, because
yeah,
with 90th percentile, 95th percentile on the LSAT or the bar test.
right. The entry level lawyer, like one without much experience, real world experience. But yes, no,
Yeah.
it's for templates. Like what I'm excited about, what I hope it helps us over is what I call the blank page, the paralysis of the blank page. This sort of, what do I do? Where do I get started?
Yeah.
Like, get me started, GPT, and then I can iterate from there. Like my son is doing a reinforcement learning problem with my brother, who's an engineer, and he's just heavily using ChatGPT to learn how do I do Bezier curves and write code to do the derivative of one, and like just let me, what does this look like? Just to kind of, and then he spent a bunch of time debugging, right? So he's been learning to program essentially by having ChatGPT produce something, then debugging the result that he puts together, right? Which is okay. That's an interesting that's interesting.
Yeah,
Like, I see it as a learning tool.
Yeah, absolutely. I've been finding, while I can't necessarily control for what OpenAI is doing in terms of updating their language models or anything like that, you can kind of tackle that, as you say, blank page problem by sort of implementing a sort of rhythm to the conversation, where it's like, a cadence of, hey, could you write me a Python class that wraps this API? I'd like to be able to handle these specific things. I've looked at the documentation. I want to be able to handle these methods, maybe throw out the rest. But let's start with that, and then I'll put it in, run it. Any errors, dump the errors back in it, and then see where it goes from there. And it doesn't always get things right, even in the first few iterations, but just by having that back and forth and effectively just having infinite patience of a machine on the other versus like, say, for example, I wanted to talk to you about something, I'd probably get a little bit better guidance than an average Python expert. However, I'd still be, taxing your attention, taxing your schedule.
Right.
And I want to respect that.
I love that use case, actually, because I think one of the challenging parts of bringing new people on board, always, like I love hiring interns, love hiring new people. The trouble is they're really expensive. Like they're not expensive, but it's expensive to take really talented people and have them spend all their time training this person. Right?
Yeah.
They usually love to do it, so it's not, the social aspect of it is actually a plus. But from an economic perspective, it's actually, can they get interns to ask better questions? Like if you saddle them with ChatGPT, now can they kind of build better questions to bring to the table?
Yeah, and so many of those questions are going to be detail oriented. They're not necessarily stylistic, which is the real value of a senior. They're going to be like, how do I get access to this part of the code base, or how do I get access to this tool, or who do I need to talk to about this repo, that sort of thing, where it's just like one dumped into this situation. And then, it makes sense in the present situation to ask a senior because they probably know. But like you said, that's overhead that is not just about the training of that individual, not what's in the training.
That's right. Like we run an intern program at Quantite. We're doing just another one this year. Quantite Labs has a great intern program, but the big effort of it is to find the mentors. We've implemented a program we call Residency, actually, at Open Teams Global, where we basically it's a way to connect someone who's just learning. It's borrowed from the medical profession, the residency program, where you get someone who knows stuff, but they're not really that experienced, and you pair them with a mentor who works with the client too. So the client has access to a high bandwidth person to have conversations with, and then that person can spend time translating and helping the person come up to speed quickly. And then, with 2 to 4 hours a week of interaction, the mentor can make a big difference for the intern, and to the point where the client's actually pretty happy with the result. And then the program is intended for the person to get hired by that team. But that's an example of, could we make, could ChatGPT, could these language models help in that process to facilitate, the time? Maybe. Like, I'm hopeful. I'm also interested to see if, like, there's a lot of open source code that needs better documentation and needs better tests. And you could just say, oh, auto do it with ChatGPT, but my view is like, well, maybe not auto do it. What if you just had a program where you got people who are trying to contribute to projects, use it to generate some tests, but then they get those tests accepted by the community. Like, they actually, hey, here's my pull request, here's the test. So they take ownership of the result, but it helps get them doing it. Whereas if they had to write it by hand, and they wouldn't get there. So I don't know, maybe there's a way to use this to kind of onboard more contributors. We'll see. But anyway, super fun to talk to y'all. It's past my bedtime.
Yeah, well, I won't bug you too much in the future, but we'd love to have you back. This has been probably
that's kind. No, I'd love to come back. It's a great group of people here, and I have family in the area, right, Jared?
Yeah. All right. Well, Travis, we'll let you go.
Right, thanks.
We're past what you were saying was your hard stop, so I appreciate you leaving.
Bye, Travis. I love you.
You're kind. I appreciate you guys. Thanks so much. You guys have a great night.
I love you, Travis. I love you so much.
Bye now. Goodbye.
Thanks again, Travis. Awesome. Well,
thanks for having us.
Yeah, of course. Well, okay. So at this point, we can leave the floor open. We're definitely well past the time that we had allotted, but if anyone else had anything they wanted to jump in with, I don't know, show and tells or something, or they just wanted to talk about speaking in the future, now's a good time. Otherwise, I'll start wrapping things up, but that was exciting. Thanks again to Travis for coming out. That was awesome. And thanks for everyone showing up. We do this every month, first Thursday of the month. Hopefully you've joined the Discord or Slack or both. But if you keep an eye on any of those social media channels, most of them will get some details on next time around. Definitely join the meetup, though. That is definitely the source of truth at this point. All right. Well, sorry to anyone who didn't get any questions in. But yeah, it's a half an hour past allotted. So thanks again, everyone. See you in a month.